Hello everyone, welcome to a new video. So let us discuss the problem of the day, that is count possible ways to construct building. Let's see the problem statement. There is a road passing through a city with n plots on both sides of the road. Plots are arranged in a straight line on either side of the road. Determine the total number of ways to construct the building in these plots, ensuring that no two buildings are adjacent to each other. Specifically, buildings on opposite sides of the road cannot be adjacent. So the star is used to represent a plot and this or sign is used to represent a road. And according to the question, we are given with n number of plots. We have to decide or determine how many buildings we can construct in those plots, provided that no two buildings can be adjacent to each other and the building opposite to the road is not considered as adjacent building. So these are the two conditions given in our question. Now let's take some example for better understanding. So when n is equals to 1, that means we have only one number of plot. So this is the possible condition. This is a road and these are the two plots. So what are the possible combinations of construction? That is, here we can build a building or we can leave it blank. So there is two possibility for one side of the road, and for the other side also the same combination will be there. That is, we can build the building or we can keep a space over there. So the total number of ways to construct building on either side of the road is 2 to the power 2, that is 4. Now let's say if the number of plot given is 2. So this is the road and two plots are given on each side of the road. So let's see the possible combinations over here. This plot can be a building and it can be a space. It can be a space, this can be a building. We can take two spaces also. And the last condition can be this, where two buildings are adjacent to each other. But in our question, it is mentioned that no two buildings can be adjacent to each other. So this is not considered as a possible way. Hence, we are left with three possible conditions for one side of the road. And the total number of combination for both sides of the road is 3 to the power 2, that is 9. Because the combination over one side of the road will be same as the other side of the road. That is why instead of calculating it for the second time, we are simply taking the square of our result. Now we will discuss when the number of plot given is 3. That means in either side of the road, we got 3 number of plots. Now let's see the possible combination. So it can be a building, building and building. Then we can say building, building and a space. Building, space, building. And accordingly there will be 2 to the power 3 number of combination because we have 3 spaces, right? So we will get 2 to the power 3, that is 8 number of possible combinations. So let us write those combination quickly. Space, space and space. That means there is no building in either side. So these are the possible combination. But according to the question, two adjacent buildings cannot be constructed. So this is not possible. This is also not possible because two buildings are there adjacently. This is possible. This one is possible. This is also possible. It is not possible, and rest of the two are possible combination. So we got 5 possible conditions in each side. So for both sides, total number of possible construction is 5 to the power 2, that is 25 number of constructions. Now how to solve this problem? If we see the number of possible ways for each number of plot, that is 2, then we got 3 for n equals to 2, then we got 5 when n was 3. So basically it's forming a Fibonacci series. We can see that. So for n is equals to 3, according to the Fibonacci series, we add up previous two values to get the current value. So n minus 1 plus n minus 2. So n is 3, n minus 1 is 2. The value or the possible way of construction at n equals to 2 when the plot was 2 was 3. And in n minus 2, that is when the number of plot was 1, the possible ways of construction were 2. So we will add up those and we will get 5. The number of possible ways when the number of plot given is 3. So if we follow this Fibonacci series, in n equals to 4, we will add up previous two values. n minus 1 and n minus 2. So 4 minus 1 is 3. The possible ways of construction when the number of plot given were 3 was 5. So 5 plus n minus 2 is 2. When number of plots were 2, we got 3 as our possible ways of construction. So we will add up these two values and we will get 4. So 8 is the total number of possible ways to construct building when number of plots given is 4. So we got the basic logic how to solve this problem. Now let's get into the code. So in the question it is stated that the answer can be very large. So print it in the mod of 10 to the power 9 plus 7. So we will take this value in a variable long mod equals to. Then we will take a dynamic array which will store the number of ways to construct building in each side of the road. So let us create an array long dp equals to new long, and the size will be n plus 1. And for the base cases, we will add 1 in our 0th and first index of a dynamic array. Now we will start iterating from our second index of the dynamic array, and I will be less than equals to n, and I will increase by 1 after each iteration. Now as we have discussed, the number of possible ways to construct building when the plot is given as I. Here we are starting with I equals to 2. So we have two plots. In that case, we will add up the number of possible ways to construct a building in previous two cases. That is in dp of I minus 1 and dp of I minus 2. When I will be equals to n, it will get out of the loop and we were left with the sum of last two indexes. So we have to calculate that. Let's take a variable res where we will store the last two values of our series, that is dp of n and dp of n minus 1. By this we will get the total number of ways for one side of a road, and then we will square it to get the total value. So res equals to res into res, and at last we will return our calculated value. And according to the question, the input value can be large, so we have to perform modulo operations on our results to get a smaller value. And at last we can see we have to return an integer type value, so we will typecast it because we have taken long type res. And this is all about the code. If you have any confusion with this part of the code, let us understand it. And if you are aware of it, please skip the video where I will compile and run my code. So this was the part of the code, and we are storing our values in array. So we will start with 0th index, and let's say we are calculating for four plots. Our base case was for 0 the number of possible ways is 1, and for 1 possible ways is 1. From 2 we will be start our iteration, and we will add up previous two values to get our result. So 1 plus 1 is 2. We will add in that index. Next time when our I was 3, we will add previous two values, that is 2 plus 1 3. And for the last time when I is equals to n, we will add last two values again. So 2 plus 3 is 5. Now as we are following zero based indexing, all the values are storing in the next indexes, because for n equals to 3 we have calculated, we got 5 number of ways on each side, so it is stored in the next index. In the same way, for I equals to 2 or n equals to 2, the number of ways were calculated as 3. It is also stored in the next index. Thus, to get the number of ways of constructing building when n is equals to 5, we have to add up the present value with the previous value. That is what we have done in this variable, where we are storing the addition of last two index. So let's see, 5 plus 3 is 8, and that is the number of possible ways we have calculated previously. When n is equals to 4, we will get 8 on each side. If you are not yet cleared with this logic, let's take n equals to 5. So in the last iteration, the value will be 5 plus 3, that is 8. But this is the value for 4. The exact value of 5 will be calculated as the present value plus the previous value, that is dp of n plus dp of n minus 1. Hence we will get 13. So this is all about the code. Hope it is all clear. Now let's quickly compile and run our code. So our code is compiling fine. Let's submit our code. So our code has successfully passed all the given test cases, and we have achieved the expected time and space complexity as well. If you find this video helpful, please like, share and subscribe, and let's meet in the next video.